Let's show that additive inverses in the integers are unique. But before we do that, let's see what we are assuming, what properties or what axioms of the integers we are assuming to prove this. Because, well, if one of the axioms of the integers is that additive inverses are unique, then we're done. So what are we assuming and where do we start from? First, the integers have an addition binary operation, and the integers are closed under that operation, so the sum of two integers is an integer. Second, there is a zero element in the integers, a neutral element with respect to addition, such that any integer plus zero is the same as zero plus any integer is that integer. And third, for every integer, there is another integer, which is an additive inverse. So n plus that integer, or that integer plus n, is zero. Notice that I'm only saying that there is one, but not that it's unique. That's what we want to prove. Now for the proof, suppose that you have two integers that are both additive inverses of a given integer n. Then what we know is that, well, a is an additive inverse and b is an additive inverse. And if a plus n equals 0 and b plus n equals 0, then a plus n equals b plus n, and then I can add a to both sides, and I get a plus n plus a is b plus n plus a, and I should have mentioned that addition is associative, so this is also a plus n plus a, and this is also b plus n plus a. But now n and a is an additive inverse of n, so this is 0, and this is 0. Then this is a plus 0, this is b plus 0, but by the property of 0, this is a and this is b. Therefore, a equals b. So the two additive inverses that we had in the first place, they're actually equal. And this is how we usually show that something is unique. We assume there are two, and we show that every time there are two with that property, they're actually the same. So there is always just one unique element that is the additive inverse. By the way, the same proof works for any group, any abstract group where you have a binary operation that is associative, there are inverses, there is a neutral element, and you can prove that those inverses, the inverses with respect to that operation, are unique using the same method of proof.